Hello student, this is Ravi sir. From Devashay International Public School, and today I will be teaching you mathematics, one of the chapter of mathematics, that is factorization. So students, before we start up with the proper chapter, let's just revise some of the things which we have already learned in our previous classes, and then later on we will just go through some of the basic concepts, and then later on we will continue with the exercises and our sums, right? So let's start with factorization. Now see, before we understand the factorization, students, we have already learned the factorizing some of the numbers, natural numbers, in our previous classes. For example, let's take one of the natural number here, that is 30. We can also write 30 as 2 into 15, right? Both 2 and 15 are the factors of number 13. We can also write it as 3 into 10 and 5 into 6. So number 1, 2, 3, 5, 6, 10, 15 and 30, all of these numbers are actually the factors of this natural number 30, right? So these are the factors. Now just look at this. Number 2, number 3 and number 5, these are actually the prime numbers, right? So number 2, number 3 and 5 are actually prime factors. Okay? Because these numbers are actually the prime numbers, so we call them as a prime factor. Fine. We can also write this 30 as 30 is equal to 2 into 3 into 5, right? Because these numbers 2, 3 and 5 are actually prime numbers, these are known as the prime factor form. So this way, this is known as the prime factor form. We can take some of the examples like 70. So we can also write the prime factor form of 70 as 2 into 5 into 7. We can also write the prime factors form of 90 as 2 into 3 into 3 into 5, right? Now, one very important thing which I would like to make you understand, student, is that we can also write 30 as 1 into 30, because that means 1 and 30 both are factors of the natural number 30, right? But we do not write 1 as the factor, because unless and until it is specifically required, fine? Otherwise, we do not write 1 as the factor, fine? Now after that, students, we will study like the factors of algebraic expressions. Basically what we are going to do in this chapter is we are going to factorize the algebraic expressions. That is the reason we start with the simple numbers, and then we will learn how to factorize the algebraic expressions. Now students, in algebraic expressions, terms are formed as product of factors, right? In algebraic expressions, the terms are formed as product of factors. Let's just understand this concept. Let me just write an algebraic expression. 5xy plus 3. This is an algebraic expression. This is a binomial, because we are having two terms here. This is the first term, 5xy, and this is the second term, 3x. So let's just take the first term. This is 5xy. How can we write this 5xy? We can write this 5xy as 5 into x into y. Right? 5, x and y, all of the three are the factors of this first term, 5xy. So we call this as the irreducible factor form. Fine? You can say 5 into x into y is actually the irreducible factor form of 5xy. Alright? Now, some of the very important things which we should keep in our mind before we go to the chapter. Factors 5xy cannot further be expressed as the product of factors. Fine? Because these are already in a reduced form. They cannot be further reduced. So that is why the factors 5, x and y cannot further be expressed as product of factors. Fine? And so we may say that 5, x and y are actually prime factors of 5xy. These are prime factors of 5xy, because these numbers 5 and these two variables x and y cannot be further reduced. Fine? And one more thing we should keep in this in our mind, students, that in algebraic expressions we use the word irreducible in place of prime, right? Okay, just take an example. We took the first term of our algebraic expression 5xy here, and we have written this as 5 into xy. We can also write this as 5 into xy. So this is not irreducible form. In fact, this is reducible form. Why? Because again xy can be further reduced as x into y. Fine. So this is in fact irreducible form. We can also take some of the other examples like 3x into x plus 2, which can be reduced like 3 into x plus 2. Again 10x into x plus 2 into y plus 3, this can be reduced as 10x can be written as 2 into 5 into x plus 2 into y plus 3. So these two examples are the examples of irreducible factor form. Okay, well student, now let's understand a new topic here. Now what is a factorization? Now to understand what is a factorization, to factorize an algebraic expression we simply write it as product of factors. To factorize any of the algebraic expressions we simply write it as product of factors, right? So what can be a factor of an algebraic expressions? Factor of an algebraic expression can be a number, or it can be an algebraic variable, or it can be an algebraic expression also. Fine. So let's just take an example. I have written some of the algebraic expressions here. See, 3xy, 5x square y, 2x into y plus 2, 5 into y plus 1 into x plus 2. These are some of the algebraic expressions here. Now these algebraic expressions are actually called the factor form. Why? Because the factors of these algebraic expressions can be find out by simply looking at it, right? So let's just check it. The factors of these algebraic expression is 3, x and y, and it can be written as 3 into x into y. And let's just take this. The factors of these algebraic expressions is 2, the second factor is x, and the third factor is y plus 2, and it can be written as 2 into x into y plus 2. So we simply find out the factors of these algebraic expressions by simply looking at it. That is the reason it is called the factor form. Now just look at these algebraic expressions here. 2x plus 4, 3x plus 3y, x square plus 5x. These are not in the factor form. Why? Because we cannot find out the factors of these algebraic expression by simply looking at it. So how do we factorize now? So our next topic is methods of common factors. So we need to find out the common factors. Let's just take the first algebraic expression here. It is 2x plus 4. How can we write these algebraic expressions? We need to write each term of this algebraic expression in irreducible form. We can write 2x as 2 into x, plus we can write 4 as 2 into 2. Now you see, in both the terms we have 2 as common. In this term we have 2 as common, and again here in this term we have 2 as common. So we take it out, and the rest of the things we put it in our bracket, right? This x and 2. So we have, we got it here 2 into x plus 2. We can call this as a factor form. Why? Because we have brought these terms in irreducible form. We can simply find out the factors of these algebraic expression by simply looking at it, right? One of the factor is 2 and the other factor is x plus 2. Fine. So this is the product of irreducible factor. Okay students, now let's just check out factorization by regrouping the terms. Sometimes we have algebraic expressions in this form, that is 2xy plus 3 plus 2y plus 3x. Now there is not a single factor, students, which is common to all these four terms, right? There is not a single factor which is common to all these four different terms. So in this case, before factorization, we need to actually rearrange or regroup these terms. So let's just solve this. 2xy, now again next term is 3. So instead of that, we bring this 2y this way. 2y plus 3x, and we write this 3 and the last. So we have rearranged it, and now we can bring this each of the term in its irreducible form. So let's just write the first term, 2 into x into y, plus this can be written as 2 into y, plus 3x can be written as 3 into x, and the last term plus 3, right? So we just group these all terms in two terms we bring together, right? So these two terms together and the other two terms together. Now just look at these two terms. We have one number which is common to both the terms, that is 2. Again we have one more variable, that is y, which is again common to both the terms. So we bring this out. That means we take these numbers and the variables as common, right? So we take it out 2y and write rest of the thing in the bracket. That is x and plus 1. Okay, we will proceed further. Again plus. Now see, these are two terms. What is the number which is common to both the terms? That is 3 here and again here. So we take this out. That means we take it as common and put the rest of the thing in the bracket. That is x plus 1. Again you see student, on both the side of the term we have one more thing which is common here. That is x plus 1 here, again x plus 1 here. The second time we take this as common. So x plus 1 and we put rest of the thing in bracket. That is 2y plus 3. So we have factorized it. That means we have brought these algebraic expressions to its irreducible form, or we can call it as a factor form. Why? Because we can find out the factors of these expressions by simply looking at it. So one of the factor is x plus 1 and the other factor is 2y plus 3. So these are irreducible form. Now how was this possible? This was possible after rearranging these algebraic expressions, after rearranging the terms of the algebraic expressions. Otherwise it won't be convenient for us to factorize the algebraic expressions. Okay. And one more thing student, we can also factorize some of the algebraic expressions by rearranging in two or more than two ways. Fine. Alright, students, now we will begin with the exercise number our 14.1, that is our first exercise, right? So we will begin with the first sum, that is find the common factors of given terms. We are given some of the terms here and we need to find the common factor, right? Okay. Now see, for finding the common factor, students, we need to reduce each of the algebraic expressions or each of the term of the algebraic expression. Let's take the first term, that is 12x, and the other one is 36. We need to first reduce them, right? So 12x can be written as 2 into 2 into 3 into x. 36 can be written as 2 into 2 into 3 into 3. Now you see, we have reduced these both of the expressions, and now we can find out 2 into 2 is common here in both the terms, right? And again 3 is also common in both the terms. So the factors are 2 into 2, sorry, the factors are 2, 2 and 3. Fine. And the common factor is 2 into 2 into 3, that is equal to 4 into 3, and that is 12, right? So this is the common factor. In the same way, we have one more here, that is 6abc 24ab square 12a square b. We have three different terms and we need to find out the common factor from all the three different terms. So let us first write the first term, 6abc, which we can reduce as 2 into 3 into a into b into c. The second term is 24ab square, which can be written as 2 into 2 into 2 into 3 into a into b into b. And the last term is 12a square b, which can be written as 2 into 2 into 3 into a into b. Now we have reduced all the three different terms, right? Now let's just look at it. There is a number 2 which is common to all the three different terms. Again we have a number 3 here which is again common to all the three different terms, right? We have a which is common to all the three different terms, and we have b which is again common to all the three different terms, right? So factors are 2, 3, a, b, and the common factor is equal to 2 into 3 into a into b, and that gives you 6ab. So 6ab is the common factor. Alright. Now we will factorize the other terms, right? So we will write each of the terms and we will put it in irreducible form. Fine. Now 16 can be written as 2 into 2 into 2 into 2 into x into x into x. Again minus 4 x square can be written as minus 1 into 2 into 2 into x into x. 32x can be written as 2 into 2 into 2 5 times into 2 into x. Now looking at these reduced form, we find out that 2 into 2 is common to all the three different terms, and x into x is again common to, not x into x, only x is actually common to all the three different terms, right? So we simply write the factors. Factors are 2, 2 and we have x, and the common factor is equal to 2 into 2 into x, that gives you 4x. So 4x is the common factor. Let's proceed. Let's come to the seventh sum. We again have three different terms. Let's first bring them into irreducible form. Okay, now 10 PQ can be written as 2 into 5 into P into Q. 20 QR can be written as 2 into 2 into 5 into Q into R. 30 RP can be written as 2 into 3 into 5 into R into P. So what are the terms we have common in all the three terms? These are the numbers. 2 we have common in all the three terms. We have 5 which is again common in all the three terms, and there is P here but there is no P in this second term, right? So P is not common. Q is common to these two terms but there is no Q here, and again R is present in second and third term but there is no R in the first term. So we just have the two numbers 2 and 5 which are common to all the three terms. So the factors, which are the factors? 2, 5, and the common factor is equal to 2 into 5, that is equal to 10. Okay, so 10 is the number which is common to all the three different terms. And again we have the last one, 3x square y cube. This can be written as 3 into x into x. Y cube can be written as y into y into y. Second term, that is 10x cube y square. This can be written as 10 can be written as 2 into 5. X cube can be written as x into x into x, and y square can be written as y into y. The last term, that is 6x square y square z. We can write 6 as 2 into 3. X square can be written as x into x, and y square can be written as y into y, and the last z. Okay, when we look at these all three terms and the reduced form, we find that there is not a single term which is common here, but there are some variables which are common. You see 5 is here but there is no 5 in other two terms. There are 2 in these two terms but there is no 2 here. But the x is there in all the three terms. So x into x is here, again x into x is here, and again x into x is here. Again y into y you find here, you find y into y here, again you find y into y here, and z is not present in the first and the second term. So the factors here The factors here is x, comma x, y, comma y, and the common factor is x into y into y. That gives you x square y square. So x square y square is actually the common factor of all the three terms. Okay students?
Okay students, we will continue with our exercise in the next video. Till then, keep practicing. This is Ravi sir teaching you maths. Thank you.